Welcome everyone to this fourth video here on chapter 17, where we're going to be talking about strong acid, strong base, strong acid titrations. Okay, so let's consider strong acid, strong base titration, where in my beaker, right, I start off with an acid. Okay, so I start off with some acid in my beaker, right? Right. Again, let's say it's HCl. Okay. In my beaker, right, so I got some very acidic solution, right, which means it's a very low pH, okay, and then what I do is I start titrating that with sodium hydroxide, right, my strong base, okay, and I'm starting to, right, as I'm adding in my strong base, right, the pH starts to increase, now very slowly, but it does increase, okay, right. It's that kind of first phase of the titration where we have this partial neutralization. Okay, right? The reaction that's going on is this reaction given up here, right? That is the chemical reaction. This acid-base neutralization reaction is what's happening in the solution. Okay, right? These are strong acids, strong bases, so we got no equilibrium we got to consider. Okay, and then the equivalence point, right, is when I've added equal amounts of my base, is I have acid. Okay, at equivalence point, the pH here is equal to 7. Okay. The pH at equivalence point is 7 because I have equal amounts of acid and base that have been added to the solution. They've all reacted to form a strong electrolyte, sodium chloride, which is a bunch of spectrated ions, and water, right? So this is just formed salt water, which has a pH of 7. Okay. And then once I keep on adding my strong base past the equivalence point, right, I then start just diluting the concentration of the strong base and make this solution more and more basic, right? Notice that near the equivalence point, okay, for a strong acid, strong base reaction, right, I have a very quick change in the pH, right? And so if I have some sort of indicator, right, that changes colors, you know, around any pH kind of in this range, right, you know, changes colors from pH of like 5 to 9 or 5 to 10 or whatever, right, I will be able to detect kind of where this equivalence point occurs, right, because it's just such a drastic shift in pH so quickly, right, with the addition of that strong base, right. Okay, and so this is what a titration curve looks like for any strong base and strong acid, or strong acid, strong base titration. Okay, right. Again, right, just kind of looking at molecularly what's going on, right? You start off with your strong acid, you have some partial neutralization where you've consumed some of the H+, right? You're left with these spectator ions, right? Then you get to complete neutralization where you just have salt water in solution, and then afterwards you start adding just some sodium hydroxide to the solution to kind of dilute things, right? Now, with a strong base being titrated with a strong acid, right? So in this case, let's pretend, right, I have my beaker and it contains, right, sodium hydroxide, okay, and then I'm adding to it, right, hydrochloric acid. Right? Let's just say this is HCl, right? I'm adding, right? In which case now I start off with a very high pH because I have a very basic solution, right? It's very large pH. pH again doesn't change very significantly with the addition of the strong acid till I reach near this equivalence point, okay, right, where then I have a very large shift in my pH for a very small addition of my acid. The equivalence point is at a pH of 7 again, right, and then eventually I'm just diluting my strong acid to make a very acidic solution. Okay. So that is acid-base titrations, right? Fairly straightforward, very simple, very easy titration.